All right, good morning, ladies and gents. Just like any other notes, make sure that you're not listening to music. Focus on the notes. Of course, stop if you need me to slow down so you can kind of recopy it. Also, stop if you need to ask me questions. But in the end, our goal today is to get you some more tools so we can finish this year out really strong, especially in the realm of proofs, which is really going to be the last push that we'll see for this first semester. So go ahead and pause the video a sec, obviously catch up, get the questions down, get the format down, and then let's get started. All right, so the big question we're going to answer today is what are important angle relationships formed when lines intersect one another? So the reason this is a question is because what you have right now is like really super limited. And so if I ask you to prove something, all you can do really at this point for sure is to calculate lengths using distance formula, Pythagorean theorem, calculating slopes, maybe tell me if they're parallel or perpendicular, but there's not really much else you can do. And so we're super limited, one, just to be proving shapes, which is not really all that interesting, but also with the tools that you have to actually prove those shapes. And so this is going to be the big push today. I need to get you some more tools. In fact, you're going to incorporate 6 more things today. So if you talk about like upon what these angle relationships are based, we have to first kind of start with this big idea. The big idea is really just how can you determine angle and side relationships without a graph? Because that's going to be the thing. So if you don't have a graph anymore, because that's where we're limited right now, if we take away the graph, now what can you do? And so we have to start out with 2 governing, I guess you can call them, ideas. Something called the angle addition postulate, another called the segment addition postulate. Now this term postulate is not one that should be too confusing. A postulate is just really an idea. And so it's an idea, you can call it maybe a rule or maybe a law. These are all kind of the same things. And so this is the angle addition idea, the angle addition rule, the segment addition law, if you will. Now, if you can kind of break down the word angle addition, segment addition, that hints at what we're going to do. We're just going to add things together. And so the angle addition postulate, the segment addition postulate just basically say if you have an angle or you have a segment, you can add the pieces together to get the whole thing. We can see that in action almost immediately if we look at these 2 examples. On the left here, we have this big angle ABC. Recall that angles are named in order of their vertices or points along the outside. And so we have A, we have B, we have C. Then we have these 2 angles in between. We have this 10x minus 20 degree, which is expressed algebraically, but that's not a big deal. And we have this other angle that's 2x plus 10 degrees. But we do know that the entire angle is worth 110 degrees. So from here all the way to here, that's 110 degrees total. And so if you think about the angle addition postulate, the sum of the parts is equal to the whole, what this allows us to do is to set up an equation. And so we can basically say that if we have one thing, one angle, we add it to another angle, that's going to equal the total angles. So this is like angle 1, this is like angle 2, and this is the total angle. And that's all the angle addition postulate tells us is that we can do this. And so we can take the first angle, that's 10x minus 20. We can take the second angle, that is 2x plus 10. And we can set it equal to the total, which is just 110. And so the justification for this equation, okay, is actually the angle addition postulate. So it's no longer like a calculation on the grid, now it's reasoning and logic based on rules. Now we can finish this up by simply solving this. So we add the x's together, we have the 10x plus the 2x, that gets us 12x total, minus 20 plus 10, it should be minus 10, and that's equal to the total of 110. Okay? Now algebraically speaking, now you just have to solve this out, so we'll just add 10 to both sides to solve for x. And so we have 12x equals 120. We can now divide both sides by 12. And that gives us x to be 10. Now, once we have x equals 10, we can come back up here and actually solve out these angles. We can take 10, stick it right back in here in our original equation. 10 times 10 is 100, minus 20 equals 80. And we can do the same thing for the secondary angle. 2 times 10 is 20, plus 10 is 30. Now this should work out because the total is 110, 80 plus 30 is 110, so that confirms we did the job right. And so again, now you see a switch here, it's no longer calculations on the grid, but rather something algebraically kind of derived. This is a segment addition postulate. But we're going to work on the same principles. Two parts added together equal the whole. And so we have like segment 1 plus segment 2 equals total. Okay? And so if we take this first part, the 5x plus 5, we can add to the second part the negative 2x plus 25, and that should equal our total, which is 45. And so the justification for this equation is the segment addition postulate, the segment addition rule, and now we just simply add all the pieces together. 5x minus 2x gives us 3x's, 5 plus 25 gives us 30, and that's equal to 45. So we're able to set up an equation and now solve for it. And so algebraically, we subtract 30 from both sides. 3x is equal to 15, divide by 3's, x is equal to 5. And so now that we have this x value, we can go back and resubstitute it. So if we go back to the top here, 5 times 5 is 25. 25 plus 5 is 30, so that's the length of this piece. 5 times negative 2 is negative 10, so subtract that from 25, we get 15. And that confirms we're right because 30 plus 15 does equal that 45. And so let's see some derivations on that now. So that's the segment and angle addition postulates. Let's talk about linear pairs. Now linear pairs, as I erase this, is also sometimes called the linear pair postulate. And so again, you have the word postulate pop up. So recall that, please, this is just like a rule or a law. In other words, it's just something that you can follow. It's a relationship that happens all the time. So as we're kind of going into the linear pair postulate, let's look at the sentence frame. And so linear pairs, if you kind of break down that word, linear means line, pairs means things together. And so no surprise here, linear pairs refer to angles that either form a line or that results when a line is divided into parts. Okay. And so if you look at the two examples below, that's exactly what we have going on. We have one line here, also called a straight angle for what it's worth. And that line is now divided into multiple pieces. We have an angle here, and we have a second angle on the other side. Same thing here. We have one angle, two angles. And so this is very much like the angle addition postulate, except the total is not something that's going to change a lot, because what we find, since we have a straight angle, and an angle is always equal to 180 degrees, is that linear pairs are always what we call supplementary. And the definition of supplementary means that they sum total, or add, I should say, to 180 degrees. Okay, so the idea of supplementary, the definition of supplementary, just means things add to 180 degrees. And so there's a connection between these two terms, supplementary and the idea they add to 180 degrees. Either way, they give us a justification to set up another equation. So if we have this line that equals 180 degrees, and we have two parts, our equation should be the two angles added together equal 180. Okay, so this is like angle 1, this is like angle 2, and instead of being a variable total, this will always be 180 degrees because it forms a line. And so like one part of it is x, the other part is 63. They come from these two angles right here. And so we actually now have this nice equation, x plus 63 equals 180 degrees. So here, of course, we can solve it, so subtract 63 on both sides. Okay, so we borrow that, make it 7, so that'd be, let's see, 7, 1, 1. So 117 degrees is the x. Now we can confirm we're right by sticking that number right back up here and looking at the total. So 117 plus 63 should equal 180. And we can confirm it absolutely does, which means we're correct. Now the problem gets a little more complicated in this example, but again, the frame starts the same way. Two things add together to make 180 degrees. Those two things have to be these equations. And so we have the 7x minus 14. Okay, then we have the 2x plus 5. And those equal 180 degrees, again, because we have this line that they form together. A line is always equal to 180 degrees when you go from one end all the way to the other. That's always 180 because of the line itself. It's half a turn, it's half a 360. And so now we can solve algebraically. So 7x plus 2x, that gives us 9x. Negative 14 plus 5, that should be plus 9, or minus 9, excuse me. Okay, and that's equal to 180 degrees. We can add 9 on both sides. And so 9x is equal to 189. Divide by 9, divide by 9. We're in a room. X is equal to, let's see, that 9 goes in 18 twice, 21. So x equals 21. And so just in the interest of time, I won't go back and do this right now, but we can 100% take that number, stick it right back in here for x, and then figure out what each of those individual angles is worth, because they both must equal 180 degrees as a total when they add it together. Okay? So let's now progress to something slightly more complicated. So let's talk about vertical angles. Now, vertical angles, this concept is sometimes also referred to as a vertical angle theorem. Theorem is no different than a postulate. It's just like a postulate. Okay, which means that it's like a rule, it's like a law, it's just a geometric word we tag onto this concept. So vertical angle theorem, vertical angles, they have a relationship. So let's go to this, the sentence framing over here. So vertical angles are angles that are across from one another. When the two lines intersect. Okay, so let's pause here and let's make sure we understand that. Now, often this is sometimes called the scissor theorem. Sometimes, well, you hear me say it in class, that the vertical angle theorem is sometimes also referred to as a scissor theorem. Because that's exactly what you should have in your head when you're thinking about this. And so we have these two lines, so line number 1, line number 2, and they operate a lot like scissors. So if you close the handle on the scissors, like you close this handle right here, the blades at the other end also have to close. Likewise, if you raise the handle, separate the handles, the blade has to open as well. These are actually what dictate the angles. So when we're talking about vertical angles, we're actually talking about the ones that occur here and here. So angle 1 and angle 2 are vertical. There's another pair here, 2 and 3. These are also vertical. So 1 and 3 are vertical, 2 and 3 are vertical. And you can see kind of like with this this idea that why we call it sometimes the scissor theorem. And so let's make a little note here. Angle 2 and angle 3 are vertical angles. So angle 2 has to be congruent to angle 3, because that's going to be their relationship. Vertical angles are always congruent, which means they have the same measurement. Okay? So if I said angle 2 is like, I don't know, 120 degrees, then we have to say angle 4 is also 120 degrees. So if I say angle 3 is like 60 degrees, that means angle 1 is also 60 degrees. Because angle 1 and angle 2, or I'm sorry, angle 3, I messed this all up, hold on. Angle 2 and angle 4, sorry about that. Angle 2 and angle 4 are vertical. Angle 1 and angle 3 are vertical. So angle 1 has to be congruent to angle 3. I apologize for that. That caused some confusion. It happens from time to time. All right, let's look at this example. So just like the other example with the scissors, if this angle is 35, its vertical pair, which is over here, must also be 35 degrees. Okay. Now, we don't have measurements for angle 1, but we kind of do because of linear pairs. So if you consider this to be a line and that much it's 35, that means its pairing has to be equal to 180. So 35 plus something equals 180 degrees. So we can subtract 35, And so angle 1 has to be equal to, let's see, this is 7, 1, that's a 5, 4, 1. So this is equal to 145 degrees, which means its vertical pairing, this guy down here at angle 3, must also be 145 degrees. Okay. Moving on to the example here, we have a little algebra, but again, we see their vertical angles. Vertical angles are always congruent because they're across from one another, the scissor angles. And so we can set up a quick equation here. Something has to equal something else because vertical angles are congruent, therefore they're equal. And those two things have to be our angle values. So 3x has to be the same as 2x plus 16. Now solving algebraically, we can subtract 2x on one side, subtract 2x on the other. So that leaves us with x being equal to precisely 16. Now that's not the degree measurement, of course, that's the x value, and so we can put that back in for x is here to find out the actual degree measurement. Okay? So 3 times 16, okay, actually let's write that vertically. So 16 times 3, 6 times 3 is 18, 3, 4, 48. So this is 48 degrees. Now we don't have to resubstitute in the second value because we know they're congruent, we know they're equal, so this also automatically has to be 48 degrees. Okay? Let's talk about one more and then we'll be done. Let's talk about complementary angles. Now complementary angles, notice the difference here, it sounds a lot like supplementary, so we're going to have a similar relationship. Complementary angles are angles that sum, let's write this down, to 90 degrees. Okay, or form right angles together. Okay, 90 degrees, right angles mean kind of the same thing. So the way we're going to resolve these types of problems is to kind of lean on the angle addition postulate. To help solve these. So this is kind of like the difference between like angle addition and supplementary where the total just has to be 180. In this case, the total just has to be 90. And so like in this case, we have these two angles, but since they form this right angle together, we know that their sum total is just going to be 90 degrees. And so we just have to insert the two parts. So the first angle is 72 degrees, the second angle is x degrees, so that's angle 1 and angle 2. And it turns into an equation again we can solve. From here, we can just subtract 72, and that leaves us with x being, what's that going to be, 18? And so this angle here has to be 18. We can confirm it by simply adding the two numbers together, and if that equals 90, then we're set. In this case, it 100% does, because we have 70 plus another 10 is 80, 8 plus 2 is another 10, makes it 90. Here, we're going to have a little more complication, but not too much more. Again, we know the total has to be 90 degrees, so we just have to input these two parts, 8x plus 5 here, and then 3x plus 8 here. So we know the totals are 90 because they're complementary. We know they're complementary because we see a right angle. And now we just add them together. So 8 plus 3, that'd be 11x. 5 plus 8 gives me 13. That equals 90. Now we can solve it algebraically. Minus 13, minus 13. So that's cancel on this side. We're left with 11x on this. Let's see, we'll borrow 1 here. So that'd be 7. D7 equals 11x. So let's divide by 11s. And so x equals 7 in this case. Again, if we want the value of the actual angles, we can take 7 and resubstitute. That'd be 56 plus 5, so that'd be like 61. That'd be 21 plus 8, that'd be 29. And so we can add those together, confirm that they're 90 and they're indeed complementary. Okay, so now it's time for you guys to stop, take a breath, and then write a summary. Your summaries have not been great, and so here's a way you can kind of like think about how to write a really good summary. The very first thing you should do is to reread your notes. Okay. 2 is to pick out key features. Pick out key features or like the important repeated information. Okay, and then just write like 2 sentences or 3 sentences that summarize the key features and also the essential question. okay? So in other words, if you go back to the very beginning of the notes, the question was, what are important angle relationships formed when lines intersect one another? And so you have a lot of stuff here in detail, but certainly hopefully you're picking out some key features, like there's ways to write equations. We're trying to hit some totals, whether that total be variable in the angle additions, or maybe set because you have 180s. There are congruence relationships. There are complementary relationships. And so when you see a summary, like the summary should actually do a good job answering the question that we started with, which are what are the important relationships, what are the important things you should know. Okay, so these are the first set of notes. There's a second set, so when you go back to Schoology, we're going to now take this information, try to kind of condense it and summarize it before you actually start your practice. All right, thank you very much.